Alright, so welcome to Systems 401, Operations Research. Has this been a long first day of classes for you?
Yes.
Yes? Okay, I'll make it longer then. How's that sound? Yeah. So I'm going to try to quickly go through the syllabus with you. I figure by now a 400 level course you can navigate a syllabus mostly on your own. So I'm definitely not going to go word by word through the syllabus with you. Okay? And then I've got a little test already. No, it's labeled Prerequisite Exam. This is mostly to be able to make sure that you're ready for the test. So after I go through the syllabus, I will hand this out and just want to make sure that you're prepared. You will not be graded on your score for the exam. You'll be graded on completing the exam. Okay, so as long as you put in an effort, you should do. You shouldn't have to worry about test anxiety. Oh no, I wasn't. You didn't tell me. You didn't send me an email ahead of time. I had to practice for the class. That's exactly right. I want to see what you're ready to do for the class ahead of time. And so go ahead and turn these on. Projecting here. Projectors on. Was it really? Yeah. So if I try to turn on the document cam, things will be better?
I don't know. Maybe. I think you just press the document button on the screen. Yes. We're doing something.
That definitely is the document. All right. All right. Yeah, I've got the HDMI into my laptop. Try that.
Try all.
I wouldn't be that bad. I think whoever's watching the video might be bad.
Hey! This is live to a summit course. Mysterious All right. So let's go ahead. All right. So let's see here. So systems. Hopefully, at this point, you're familiar with Moodle setup that we have. So we will have a Moodle course, and you click on it and get to all the information for the class. Let me just give you the password to enroll in the class. The password is math-modeling. Okay? So math-modeling is the password. No uppercase or anything like that. I'll give you a second to write that down or type that in your phones or what not, so that you don't forget it. So go ahead and enroll in that. You can even do that now while we're talking here. All right. Does anyone need to see the password long version? All right. So let's go ahead. And open the syllabus. Yeah. Here we go. Again, I'm not going to go through every little detail on the syllabus, but let me cover our highlights. My name is Jonathan Geisler. I'm a professor in the Computer Science and Engineering Department. This is now my 17th year here, but I'm also an alumnus of Taylor. I graduated in 1995 with a Computer Science Systems degree. And so I've been through the systems program like I think all of you are since you're in this class. So I'm excited to be here. This is the third time I've taught this class, and so I'm starting to figure out what works and what doesn't work. And I'm excited to go through this with you all. Operations research is not usually a name of a class that if you tell your family members, oh, I'm doing operations research, and they've got a picture in their mind of what you're doing. If you tell them I'm programming, or I'm doing marketing, or if I'm doing biblical studies, they've got a picture in their mind. But probably most of you, or your parents, when you saw this title, are like, what do you do in that class? And the answer is, as hinted by the password for the class, is we're going to be doing mathematical modeling to help with decision analysis. We want to be able to make mathematical decisions and not just some subjective decisions about how to oftentimes move the business forward. So a lot of the times we're going to be talking about minimizing costs, maximizing profit, minimizing the distance that your product travels from the distribution centers to, or the warehouses to the different retail centers that are available. Oftentimes for this class we're going to be talking in those terms of minimize or maximize, depending upon what objective we're trying to do is. And so we want to be able to formulate our world in terms of simple mathematical models. Okay, we're not going to be talking about complicated mathematical concepts. We're not doing calculus in this class. You should be prepared for the mathematical concepts in this class from your high school math courses. Okay, that you should be able to draw lines. You should be able to find x and y intercepts. You should be able to compute where two or more lines intersect with each other. And you'll see that in the prerequisite exam here. And be able to do algebraic manipulation of equations. Okay, so that's the kind of math that we're talking about. So we're going to approximate the real world using these linear systems. So and then by doing that, we're going to try to make wise decisions based on our analysis of the math. When we first start off the class, we're going to be focused more on how do we solve these math models with a pen and paper or pencil and paper approach. And the primary reason for that is because we want you to understand how these problems are solved. By the time we get done with chapter 3 of the textbook, I think your mentality is that is very tedious and time-consuming. And you're right, and that's why we're going to switch over from trying to do them with pencil and paper to having a computer solve those problems for us. But if you don't know how the computer solves the problems and what kind of gotchas might exist with those problems, you might formulate models that aren't going to give you good answers, or the computer might not even be able to give you an answer if you formulate them properly. So that's why we're going to focus maybe the first third of the class on how do we solve these kinds of problems, what are the math concepts behind that, And then once we get that figured out, then we're going to switch to using Excel as our primary tool for computation. Okay, and we're going to enter our models into Excel, and we'll let Excel be able to compute what those solutions are for us. That means that at first, the models that we build are going to be simple, simplistic even, because you don't want to be solving hundreds of equations by hand. Yeah, that's why we have computers to do it. By the end of the course, you will be doing a model for your final project that does have hundreds, maybe even thousands or more of equations that are in your model. And you definitely would not want to be solving it by hand. Specifically, the final project that you'll be working on, and this will be a team project, you and another student in the class, we'll be working on a gerrymandering project, okay? How many of you can tell me what gerrymandering is? Just a small handful, good. So this is a liberal arts experience here. You're going to be learning about a key political process, and we're going to be talking about how to computationally either cause gerrymandering to exist, or maybe to prevent gerrymandering from existing. And part of your process in this project, we're going to be having you write a position paper on what you think of gerrymandering and whether it should be done and how people should use computers in this process. A short definition of gerrymandering, for those of you who don't know, is because we live in a representative democracy, right? We split, let's take the US system here. Each state has a certain number of representatives assigned to it, right? And we have to say that this representative has a geographical region of that state, that voters in that region vote for their representative. And voters in a different part of the state may have a different representative, depending upon how populous that state is, right? Well, every 10 years we have a census, and so we figure out how big the states are, and so we reassign the number of representatives to the states based on their population. You know, hopefully this is ringing bells from you from your social studies classes, right? And we have to reassign districts every 10 years based on changes, where people have moved to or moved from, so that they're roughly equal in population. That the representative from Alaska represents roughly the same amount of people as one of the representatives from California, or a representative from Georgia, or here in Indiana, right? So the states are in charge of this process, and it may not come as a surprise to you that the political party in power may want to help establish or deepen their roots of power and intentionally structure the districts so as to, in an attempt to try to help themselves win as many of those electoral seats as possible and prevent the opposing party from winning seats. So we're going to talk about how to do that with a computer. And so we're going to build some models of elections. We're going to build some models of the geography of our states and combine them together, and we'll talk about how you might really help or hurt a political party in that process. So you can kind of look forward to that throughout the semester. Every Friday there will be a project-related deliverable that you and your teammate need to do, including this Friday. This Friday your deliverable is figure out who your partner is, okay? And I want a prioritized list of which states you would like to work on, from this is the most interesting state to me, down to this is the least interesting state to me. Give at least 3, preferably 5 states, okay? Some ground rules. You don't get to pick a state like Alaska or Wyoming, okay? That's going to be a really tough assignment. No, you have to have at least 5 representatives in the state that you're looking at, okay? So there has to be some sort of distribution of the population to those electors. As a suggestion, as a friendly suggestion, as a having watched last year the students work on this project, you don't want to do a giant state like California or Texas or Florida. You might be in for quite a few late nights if you choose to do something like that. A nice number is at least 5, 10, 12. I think the largest state that someone did last year was Michigan, as an example. They've got I think 12 representatives, maybe 15. Detroit is a big area. So that's going to be kind of driving your class time. All right, and we're going to go through process throughout the semester and learning how to model, how to solve these problems, and that's going to be your end goal for this class. All right. You can see a list of bullet points. You can read them all about all the detailed things that we're going to do, and I encourage you to do that. But are there any questions about kind of the direction of the class and the final project as well? I'll go through more of the syllabus here in a second, but what I've talked about so far, are there any questions? All right. The next thing I probably should do then, yeah. So I'll talk about the assessment, and we'll talk about the textbooks here. Notice this is not a normal distribution of the homework points that you're probably used to. You're probably used to something much higher on the assignments and much lower on the exams, okay? So I want you to know this going in, okay? The way that your assignments are going to be graded is 100% completion, please. Did you turn in the full assignment, okay? As far as I'm concerned, for this class, the whole purpose of the assignments is to help you learn what we're talking about that day, that week, okay? And so you can completely collaborate with anyone you want on these assignments. This is not about doing your own individual work so that you can check some box for me. It's about you figuring out what you know and what you don't know and learning that material, okay? That's the point of the assignment. So because I'm allowing free collaboration, I'm not going to give a lot of credit for the assignments, okay? If you decide to lie to yourself and to me about doing the assignments, that will show up really quickly on the exams. You lose big time if that's what you decide to do in this class. And so I don't have to penalize you outside of that. You will penalize yourself very quickly on that, okay? You will demonstrate your knowledge, your individual knowledge of the material to me in these exams right here, okay? There will probably be 2 exams, so each exam is worth about 30% of your grade, all right? And then the final project is basically the same way. So basically a third of the class, the exam 1, third of the class is exam 2, third of the class is your final project, okay, roughly speaking, okay? So, I want to help you learn. The best way you can learn is full participation in the class. Something doesn't make sense, raise your hand and let me know. Because if it doesn't make sense to you, it probably doesn't make sense to someone else in this class. It really probably doesn't make sense to the people watching it on the video, right? Raise your hand, interject, make sure it makes sense, okay? I want to make sure that your understanding is clear. All right. So you need to make sure you're here as much as possible, especially since I'm grading these on completion. I'm not going to accept late work on the assignments. They're due when they're due, which is basically every day of class, there's some new assignment. You can basically think of this kind of like a math class. There'll be 1 or 2, sometimes 3 or 4, but usually 1 or 2 problems each day. So you just need to get into the rhythm. What is my homework due for the next OR class? Because there's almost always going to be a homework due every single class. You just need to get into that rhythm, just like you might for any other math course that you've taken. Okay? They're not long assignments. These are not 2 or 3 hour assignments. They're intended to help reinforce that particular day's topic and content. The exams will be, I guess, extensive. They will expect you to understand how to do the models, how to solve the models, how to build the models, and they will probably take more than an hour time. We will probably have to pick a time, not at 3 o'clock on an afternoon, but maybe like a Thursday morning or a Thursday afternoon, to make sure that we can find enough time for everyone to complete that. Let me see here. Textbooks. Is there anything listed as a textbook at the bookstore? No. I was afraid of that. I had problems trying to enter books into the textbook website this year. So, as you can see, I've got 3 textbooks. So until you can get your textbooks to arrive, I will put these textbooks in room 218 for you to use. They will not be there whole semester, so don't not buy a book because they're out in 218. And you should be able to find a really inexpensive version of the textbook. This is the 12th edition of the textbook. This is the 13th edition of the textbook. You can buy the 14th edition of the textbook. There is even a 15th edition of the textbook. And they're releasing the 16th edition, I think, next year. Okay? I don't care what edition you use, because for whatever reason the authors don't change the problem set in there. Okay? So whatever is cheapest, go for it. Okay? 12 and beyond. I haven't looked earlier than that, but I have examined the editions since then. So this one's starting to get expensive because it's getting so rare. But I think this is the 13th edition is getting reasonable. The 14th edition is reasonable. Be careful. I don't know if they've got an international edition of this textbook. Be a little bit aware of that, because one thing that they often do with the international textbooks is they do change the problem sets in them. And I'd hate to have you do that. In fact, I think they actually did last year. I had one or 2 students that did that. And that's not going to help you because you'll get all the wrong stuff. So, I think for sure less than $50, maybe even less than $25 if you can find a deal. Okay? You found one for $25 right there?
I found it for like 10.
Okay, so this is not a killer textbook. Don't avoid buying it because I have a couple copies in 218, okay? Yeah, the link to it is in here. And they've added an author, whatever. So they haven't changed the problem set, and the text is minimally changed from edition to edition. It's totally a scam, right? All right, so that's the textbooks. Yeah, don't cheat. I really don't want to deal with that, and that's not affecting your learning. Well, it is affecting your learning in a very negative way. It's not positively affecting your learning, right? Laptops. In the beginning of the class, when we're doing pencil and paper, laptops are probably going to be not helpful for you because you're not going to be doing it electronically. But when we switch to using Excel, it will probably be really helpful for you to bring your laptop in. Because then, as I'm working on the keyboard and working inside Excel, you can be doing the same thing on your screen and setting up the model in Excel along with me. And I'll try to make sure that you're staying at pace with me, and I'm not just zooming ahead and doing 500 keystrokes, and you're like, wait, what did he do? Where did he click? I looked down for 1 second and there's 20 things on the screen, right? I'll make sure that you can follow along with. So definitely bring laptops when that happens. With it being so packed in here, don't use laptops other than that. You will not only distract yourself, you will be distracting your neighbor. You can't help it when we're this tight in, right? And that's not fair to your neighbor. If you're really not interested in the class, don't come. Okay? It's not nice to your fellow classmate to do that to them. All right? Yeah, so that's the main parts of the syllabus. Are there any questions that I didn't cover? Cool. Yes, good time. All right, so let me hand out the prerequisite exam. And again, just a reminder that I'm trying to get an idea of whether you're prepared for the mathematical content of the class. If something is difficult on this prerequisite exam, please come talk to me. It's not that you can't do this class, but we need to be on top of it and not just pretend like this class is going to be easy, and that you're not going to have to work on refreshing and reminding yourself of what is being done in this class here. So you turn it in, and you're free to go. Let me see if I can count to 5.